Hi, welcome to part one of three, looking at the ozone story, which is the next three lessons that we're going to be doing as part of your environmental science course. So in this first part, we're going to look particularly at what is ozone. We're going to explore a little bit about the makeup of it and why ozone is relevant to the world. We're then going to look at an issue in the next chapter. We're going to look at, for lesson two, big issue basically surrounding the ozone hole and what that means for the world. And for lesson three, in preparation for your workshop there, we're going to look at how we managed to solve an issue around decreasing the decreasing ozone layer. Okay, so for part one, our outcome is to describe the functions of the stratospheric ozone and to interpret data from secondary sources, and that's going to kind of come in the extra work we're going to do during the lecture. The third part is about calculating standard deviations from given data set, is an extra piece of maths work that you're going to do in your outside learning this week. And next week at some point, we're going to have a look at your knowledge of how to calculate standard deviations. Really essential skill and one that you need to pick up over the next couple of weeks. So you should be able to interpret data and calculate standard deviation by the end of the next couple of weeks, as sort of the first chunk that's going to contribute to your learning here. So, introduction to ozone layer. First thing I want you to do, and you should have hopefully done this already from the email, is watch the Few School video on what is the ozone layer and an introduction to it. If you haven't, pause this video, watch the Few School video. It'll give you a really nice overview of ozone and what it is, and then come back to this chunk in preparation for your first workshop next week. Okay, assuming you've done that, either gone for the link here or gone for the link during my on my email, we'll move on. So obviously you've seen the video now, but ozone basically is a form of oxygen with three oxygen atoms bonded together. Now, as we saw in the video, the oxygen, you get O2, two oxygens bonded together, and then the oxygen has a free oxygen, one single oxygen atom by itself, not bonded. It's very reactive because it's got some spare electrons, and it's going to come along, and when it's lost enough energy to be slow enough, it'll join fairly weakly, but it'll join onto the oxygen. This creates a relatively reactive compound, O3, that will react with UV and will release an oxygen again. Ozone is highly corrosive and toxic. So down in the troposphere where we live, it's actually used as disinfectant, but when it's produced, it's generally not seen as something that is good to have around. In small quantities, it's generally found in small quantities down in the troposphere. When it's found, it's considered a pollutant. However, up in the stratosphere, ozone is considered a key compound in the atmosphere that does, among other things, protect us from UV radiation. So it's seen as important up in the stratosphere and a pollutant in the troposphere. As we're going, don't forget to take some notes, because during the lesson I'll check that you've managed to take some notes on this presentation. It can be found, so moving on. It's not uniformly distributed across the globe. So we talk about the hole in the ozone layer, but also we expect the thickness or the concentration of O3, ozone, to vary across the globe. And it's thinnest generally in the equator, hole in the ozone layer aside, and it's densest in principle at the poles. And we'll have a think about why the ozone hole might then be a problem, especially as it occurs in the Antarctic Circle. So we need a way to measure the density, the concentration of ozone, and what's used is Dobson units. Now, the researcher Dobson came up with the idea of these units, and it's basically if you condense the ozone down, it's the thickness it would be if you condense it down to 0 degrees Celsius, 1 atmospheric pressure, is how thick that layer of ozone would be. Although in reality it's sort of spread all across the stratosphere, Dobson units just measures basically the concentration in a column of ozone. Now, a Dobson unit is 0.01 millimeters thick. So 300 Dobson units would be 3 millimeters thick of ozone when you condense it all the way back down. So we're not talking loads, it's like the thickness of a thick eggshell or thickness of a penny, but it is a significant amount of ozone. So I talked about it not being great in the troposphere. Ozone is highly reactive. It's not a very stable form of oxygen. And so when it's near the Earth's surface, it will react with other substances. So when it comes to rubbers and things, it will make them crack and react and cause damage. When it comes to your lung tissue, it'll react with it as you're breathing in the air and cause issues in your lungs. And you're going to find it in your respiratory tract, restricting your ability to breathe. It's also not great for plants. It stunts plant growth. And so we've got here on the left-hand side an example of a plant that's had its growth stunted because it's been in a high O3 environment, whereas the plant on the right-hand side is growing pretty healthily and hasn't been affected by O3. This has a huge impact then on farmers and agriculture and ultimately our economy if we can't get control of O3 in the troposphere. So the ozone layer is that layer in the stratosphere. So above the troposphere, below the mesosphere, there's nice, fairly stable layer in the stratosphere, which is where most of the planet's ozone is, and it's kind of where we want it to be. In the stratosphere, it protects people, animals, and plants from harmful ultraviolet rays. That's the key thing to know. It absorbs, as we saw in the video, it absorbs the ultraviolet rays. And then becomes, free oxygens and O2s, which then, once it's lost a bit of energy, maybe through IR radiation radiating away, it'll then bond again. And that cycle absorbs lots of the UV radiation that's coming through the atmosphere. So that's a very quick introduction. So during the lesson, I want you to have reviewed this quick video. I want you to have written notes. You need to have notes on the Few School video as well. And during the lesson, we're going to look at a research paper to see what's happening with the amount of atmospheric ozone in the atmosphere. See if we can draw some conclusions based on our understandings from that.